Oh hey, I'm Simon from the Ontario Science Centre. Today we'll be talking about acids and bases. Now, what was I looking for? Oh, got it. Today we're going to be experimenting with acids, bases, and indicators. What are acids and bases? Acids, like this lemon wedge, is sour to taste and can also react to metals. Yeah, sour. Acids in a solution provide hydrogen ions also. Ooh. But for bases, like the soap here, it is slippery to touch and bitter for taste. Let me just show you. Well, I've played with soap before, but yeah, it's fairly slippery. Usually bases are corrosive to organic material. No, I'm not going to do that. But bases in a solution provide hydroxide ions instead of hydrogen ions. But scientists can't taste and touch all the chemicals that they work with. You can't eat your science experiment. So what do? They use indicators. And with indicators you can determine between acid versus a base. Today we're going to make our own indicators at home. With that indicator, it's kind of like a tool. We want you to conduct your own experiments. We want you to develop your own experiment to determine the strengths of acids and bases in your own household. Are you ready? Let's make our own indicators. To make your indicator, we're going to use red cabbage today. For the first method in making the cabbage juice, we're going to chop the red cabbage into small pieces. Add that cabbage to a pot. Top it up just enough so that the water is covering the cabbage. Bring the content up to a boil and then turn down the heat. Allow it to simmer for 10 minutes. After cooking, strain the mixture and your indicator is ready. The second method is the blending method. Chop the red cabbage into small pieces. Add the cabbage into a blender and top it up with just enough water to cover the cabbage. Blend the cabbage until it's minced. Then let it steep for 10 minutes. Strain the mixture through a fine mesh strainer. Now you have your indicator. Now that you've made the indicator, it's time to experiment. Measure 100 milliliters of tap water into 3 clear containers. Mix 1 tablespoon of red cabbage indicator into each of the 3 containers. Add 1 tablespoon of acid into the first container. Stir and observe. Now add 1 tablespoon of a base into a second container. Stir and observe. Leave the third container as a control. How did the indicator in our experiment work? The indicator from our experiment was from a red cabbage. Red cabbage has a chemical called anthocyanins. Anthocyanins undergoes the same chemical reaction as an indicator. In the presence of an acid, there's extra hydrogen, changes color. In presence of a base, there's hydroxide, so it takes away hydrogen, changes color. Exactly the same thing. But there are other fruits and vegetables that have anthocyanins in them, such as our blueberries and blackberries right here. They're also very delicious. But also, look what happens to my fingers. What do you notice about the color? How do we measure how acidic or basic a solution is? We use something called the pH scale, or the potential hydrogen scale. It measures if something is basic, acidic, or neutral. It ranges from 1 to 14. 1 being the most acidic, 14 being the most basic. Where's neutral? Right down the center and number 7. It's a balance of H and OH, or hydrogen ions and hydroxide ions. Notice the scale. The scale has colors that are fairly similar to what we were just doing with the indicators. The red is acidic and base is blue. Now here's an example of mixing an acid and a base without an indicator. It's something that you might have already tried before at home. It's very simple. You have acetic acid or vinegar, sodium bicarbonate, or baking soda, and we're going to mix it together and see the reaction. Something that you might have already done. Let's try it now. Remember to always use protective gear when you're mixing your chemicals. Let's take a look. The bubbles here were a clue of a chemical reaction. This reaction was a double displacement reaction, or an acid-base neutralization. The acid here has hydrogen ions, and the base with the hydroxide ions. They react and they create H2O, water. Similar to the bubbles that we just saw, when baking using baking powder, the neutralization reaction releases gas that makes the baked goods rise. Another example is that fishy smell that comes off of the fish. That comes from a basic chemical that is inside the fish. Squeezing a little bit of lemon juice can neutralize that base, and also that fishy smell with it. So where do scientists use indicators? Environmental scientists use pH indicators to test water. pH is important to the health of living things, because the cells inside of living organisms work best at very specific pH. If it gets too high or gets too low, the cells will not work properly. Now it's your turn to ask, test, and repeat. Formulate your own hypothesis on where some of the different household chemicals that you find at home land on the pH scale. Remember the 1 to 14. Then, test it with the red cabbage indicator. Remember, a little bit of these chemicals go a long way, so you don't need a lot of it. Before you begin experimenting, there are some safety considerations. Follow all the labels on the household chemicals. Avoid contact with the eyes and skin. You can use gloves or goggles to help protect you. Do not mix any of the household chemicals. When doing your experiments, have separate cups or separate containers and separate indicators. Do not consume any of your chemicals. And, of course, follow all chemical disposal procedures as regulated by your municipality. Now, your last challenge is to create your own experiments. You're going to use a different natural indicator. So just like before, with our method in creating indicators, you're going to follow those steps, but using something different. Something that will have those anthocyanins inside of it. Repeat your experiment, test, and see if there's any significant differences in comparison to the red cabbage. Give it a shot. Oh, hey again. What are you still doing here? We already learned about acids, bases, you know how to make an indicator, you know about the pH scale. It's time for you to experiment. We'll see you at the Science Center. What was I looking for? Oh yeah, yogurt. Bye!